Hello everyone, myself Parthodash. Today I am here for a new topic on machine. So today we are going to discuss on AC machine. So as we know, so AC machine can be of two types according to the supply. So it can be classified into two categories. One is single phase machine, second one is the three phase machine. So in three phase rotating machines, so again it can be classified into two categories. One is asynchronous machine and second one is the synchronous machine. So asynchronous machine, basically it is known as the three phase induction motor. So in our previous syllabus we have already discussed this one. So in this particular lecture class we are going to start synchronous machine. So let us see in details what is synchronous machine, how it works, what are the working principle it has. So today, from today onwards, we are going to discuss about these topics. So this is the first lecture on alternator or synchronous generator that we'll do today. And afterwards, after completion of synchronous generator or alternator, we will go for the synchronous motor chapter. So first we will start with synchronous generator chapter. So in the first class we will try to find out, we will figure out what is the construction of alternator, what is the working principle of alternator. Okay, let's start. Okay, let us start. So today we are going to start this alternator. So this is the first class of alternator. So let's just see what are the topics we are going to cover today. Okay, so these are the contents. So what are the contents over here? Definition and types of alternator. Next one is the working principle of alternator, construction of alternator, armature reaction in alternator or synchronous generator, armature binding of alternator, what are the different types of armature binding it has in the alternator, rating of alternator. So these are the main topics that we are going to cover today. Okay, so first, coming to the definition of alternator. So as it is told over here, an alternator is an electrical generator that converts mechanical energy to electrical energy in the form of alternating current. So basically, we can say that in alternator, so mechanical energy is converted into the electrical energy. Okay, in the previous syllabus, we have discussed about the DC machine, DC generator. So there also we have seen the same thing. That means when mechanical energy is converted into the electrical energy, that time it is known as a generator, as you all know, basic concept. Now here, what is the difference between this DC machine or DC generator to this AC generator? The difference is that in DC generator, after generation of alternating EMF, it is converted into the DC, but here it remains same. So here we are generating AC quantity and we are utilizing that one. So what is the advantage of that one? So we can reduce the cost of construction of a generator. So that this is the reason why nowadays these alternators are widely used in the market. Okay, except those things, other things are there which for which alternators are very popular nowadays. So now let us see that this what is the application it has, this alternator, and what are the types it has of this alternator. So nowadays these alternators are all over the world, because it is a very emerging machine. Why? Because through this machine we can generate a huge amount of energy, and its maintenance cost is very less. So those are the basic reasons why alternator are very popular nowadays. So let us see what is the application of alternator and what are the design aspect. That means what are the types of alternator as per design aspect we have. So according to application, as you can see over there, automotive type used in modern automobile. So where we need automation, So nowadays they're talking about the automation. So where we need automation, there actually we use this alternator. So because the alternators can be of small type, like this small type, or the larger one. So both case it can be possible. So that's why alternators are used nowadays. Okay, next one is the diesel electric locomotive type, used in diesel electric multiple unit. So as we know, some DG set, the diesel generator, which burn diesel, and from that energy it is converting electrical energy. So there actually we use this kind of alternator. So this is actually used for where we need high power for some housing complex or from shopping mall. They're actually for very easily we can generate some power. It doesn't need any kind of power plant, and it can be movable one. That's why this diesel electric locomotives are very popular nowadays. And marine type, as we know, in different marine cases we actually use this alternator brushless type. Okay, this is a very important thing. So when we'll go for the alternator design section, there we can see that um, over the pole winding we need some kind of supply, because we know that the Faraday's law of electromagnetic induction, that there should be some flux, and that flux cutted should be cutted by some other conductor, and if this one is happening, then only there is EMF generation. Correct. So two things are main over there. One is flux should be there, and and another one is the, yeah, conductor should be there. When those fluxes are cutted by these conductors, then only there is EMF generation of EMF. So over the pole we have some field winding, and those field windings are supplied from some kind of DC generator. Those are known as the DC exciter, and that DC exciter is actually generating flux. That fluxes are cutted by the armature winding. Then in the armature EMF is generated. So for DC generator we know that there are brushes are needed, but in case of large alternator, we can use a brushless system also. So that thing we will do in the next class when we will doing for the excitation system. So different excitation system of the alternator. So there we can find out that brushless excitation, brushless DC excitation with brush excitation. So different kind of excitation we are going to find out over there. So these are the main application of alternator. Now coming to the construction part. So as per construction, this alternator can be of two types: aligned pole and cylindrical pole. So basically, so what is aligned pole, what is cylindrical pole? So those are different application. So one by one today we will going to see what are those. Okay, so first coming to the working principle of alternator. So working principle of alternator, so basically we all know. So from the school level physics we know that, so if there are two poles, and in between that two poles if we put a current carrying conductor, and if there is a relative motion between them, then there will be EMF generation. Correct. So this concept is known to us, but for better understanding I'm just very first I'm going to discuss the same topic with you. So what is there in the picture? As you can see, there are two poles, north and south, N and S, and in between that a current carrying conductor is placed. So it has terminals, as it is giving, as you can see the names are there: A, B 1 arm, C, D 1 arm. Okay, vertically placed for the present location, and it is rotating at axis small ab. So there is an axis small ab, with that this one is going to be rotate. Correct. Now, okay, so as you can see that this one is rotating in clockwise direction, so this one is rotating in clockwise direction. So when it is rotated 90 degree, okay, and when it is rotated 90 degree, see the location of AB terminal is in front of S pole, and location of CD terminal is in front of north pole. Correct. and this yellow lines are showing us the direction of current flowing through this conductor, correct? And this green lines is mentioning the flow of flux. So as the conductor location is like this and flux is cutting like this, so at this location the flux cutting will be maximum. So if the flux cutting is maximum, then the unit generation will be maximum. Okay, so first location, so if we see the first location is this, flux is flowing like this is the inside one is the hollow one. So if the inside one is a hollow one, then the flux will flow, so there will be a minimum flux cutting. So if there is a minimum flux cutting, so there will be a minimum flux generation. Then when this conductor arm is rotated 90 degree, so at that time maximum flux are cutted. When the maximum fluxes are cutted, there will be maximum number of EMF generation. So as you can see over here, and it is also written over there. And the next case, so in the next case what we can see, so in the next case we can see that again this arm is rotated 90 degree. When it is rotated 90 degree, again there will be a minimum flux cut as from the first concept, first location case. So now the AB location is below and CD location is above, and it is rotated of the axis of small AB, correct? In the clockwise direction it is rotating. Now the last point, so here see that the conductor arm is just rotated 180 degree. That means, see, it is now the AB arm is at north pole and the CD arm is at south pole. So, and here as you can see, the current direction is shown over there. From D to C the current is flowing, and from B to A the current is flowing. So we can say that at this location again maximum current is flowing through the conductor. But what is the problem? The problem is the current direction is reverse, because previous case we have seen that the current is flowing from A to B and from C to D, and here the reverse current is flowing. So if we just imagine the waveform of a sinusoidal component, so we can see that first it is 0, then it is coming maximum, then it is again decreasing to 0, then it is going for the negative maximum, again it is 0. So this is a complete cycle. So if we think like that, this one is rotating 360 degree, then one rotation of 360 degree, it is going to generate a one cycle, correct? So as we can see over this is the concept of EMF generation of any AC quantity. So in DC machine we have seen this concept, in AC machine also, synchronous generator also, we are going to see the same concept. So now coming to the construction part. So before going to the construction, I would like to say you something that this alternator is a very actually used for the generation of power. So basically these alternators are very large in size. Okay, so for the large in size, so it has a huge ton of conductors over it. So if it has a huge weight, then depending upon that it has some special features of construction. What is the special features of construction that I'm going to tell you? So before doing that, we just see what we can see over here. So it is actually a machine is just opened like this way, part by part it is replaced over here, and now we're going to see what are the parts. So from the left to right if we go, so first in the left what we have a pulley, and then we have the drive on shield. So these are the actually outer body that we can see from the outside. Then what is that? It is the rotor. Actually there is a bearing pattern thing, and then there is a rotor, main rotor, where the windings are placed. Then it is a stator, the stationary section of the machine, where again there is a winding. Okay, and then there is the end ring. So these are the outer body structure. Then what we have, gearing section, then we have the cooling system. So different sections are compiled together to make an alternator. Now in this alternator, what we can say that we know that in DC machine we have seen that over the stationary part, that is on the stator, we have a field winding. That means over the stator we have magnetic pole, over the magnetic pole we have the field winding, and in the rotor, that is in the rotor section, we have armature slot, and in between that we have the armature conductor, correct? But as I have told that this alternator basically made of a very huge size, a very large size, then what is the problem? The problem is the conductor weight is very high. Now over the rotor, generally we plot armature conductors. Now this armature conductors is actually cutting the flux and it is generating the EMF, and that EMF we are going to use. So now if we think of a large machine, large alternator, then the weight of the alternator armature conductor is very high. Now this huge weight machine, if we want to rotate, so it itself need a very huge power. So how we can reduce the running power of all of an alternator? So to do that, what we have done, to do that, we have placed the armature conductors over the stator, correct? And we have placed the magnetic poles over the rotor, maintaining that our main idea that flux should be cut. The point is, if we have to cut the flux, now if we plot the magnetic poles over the rotor, so when the rotors are rotating, the flux is also rotating, and when this flux are rotating, at that time, so around the flux we have the armature conductor. So that armature conductor is going to cut the flux, and if there is a flux cutting, there is a EMF generation, correct? So our purpose is served. So for the simplicity of the alternator, so for the reduce of the power need for the running alternator, so we have done this. Okay, so the point remember over here, that is um, in alternator the armature winding is at the stationary section. That means the at stator we have the armature winding, at rotor we have the magnetic poles or the field winding, correct? So this we have to remember. Now coming to the stator section, so what is as you can see, so a small stator I have placed on the right hand side, and a large stator as we use in the industry, that picture I have placed in the left hand side. So what we can see in the stator is the stationary part of the alternator, already discussed, and contains three-phase armature winding. Already I have told that in case of large alternator, the armature windings are on the stator part. So stator core is built up silicon steel lamination to reduce. Okay, so those concepts are already known to us, that to reduce eddy current loss, we are going to use steel lamination, so that we can minimize this eddy current loss. And this laminated stator slots are placed in the inner periphery. The stator is something like this in a circular section in cylindrical shape. So its inner periphery, those are the slotted, and in between those slot three-phase armature conductors is placed. Correct? And next coming to the rotor section. Okay, so this is the rotor. So again I have plotted two rotor, one is for small rotor size and one is industry use rotor picture I have placed over here. So here what we have written, that the rotor is rotating part of the alternator, okay, already known to us. It carries a field winding which is supplied by a DC current. Already I have told you that when there is a field, to excite that field we need some supply. So since that supply is given from some separate DC generator, so that's why it is known as a DC current is supplied. Okay, and then that DC supply is known as the exciter of the system. Okay, and it is connected or mount over the shaft of the alternator. Now we are coming to the next part. Again, this rotor, as per its construction, it can be classified into two categories. What are the categories? Saline pole type and cylindrical pole type. This now coming to the saline pole type. In saline pole type, alternators are basically used where we need a it cannot be used for the high speed. It is used for the lower speed. Correct. So in hydel power plant or hydel station, actually this kind of alternators are used where we doesn't have a very high speed. And what is the constructional features it has? The saline pole rotor has projected outer part. So that projected outer part, again over that we have a damper winding. So what is the utility of this damper winding? Damper winding is placed, so say suppose in the with the alternator we have connected some load and suddenly we have reduced the huge amount of load. So if in the alternator huge amount of load is decreased, then what will happen? There is a vibration. So deduce that due to that vibration, there may be some mechanical damage. To protect that mechanical damage, so we actually use some kind of protection. So that protection is given by the damper winding that actually wash out that vibration from the system and try to maintain some stability in the system. Okay, so as we can see that the saline pole alternators are slow speed machines, already told. Speed varies from 150 to 600 rpm. These alternators are driven by hydraulic turbines. Okay, so in hydro power plant actually they were used, though that's why it is called water wheel generator or hydro generator also. Okay, um, saline pole type rotor has non-uniform air gap and 2 or 4 poles. So that is very important. As see, just think about that. There is a stator which is cylindrical in shape, correct? And inside that we have the rotor. Now this rotor arms are outer. So as we can see, or we can say that the distance between the stator and rotor is not uniform. If the distance is not uniform, then we can say that in between that whatever air gap is there, that is not uniform. If that is not uniform, the EMF generated, that is not uniform. Now the outer part, the outer uh, shell of the saline pole type is a radial in shape. Radial means like this, half circle. If it is half circle or radial in shape, then what will happen? Whatever EMF is going to be induced, that will be sinusoidal in nature. So intentionally this kind of structure is given to the saline pole machine so that we can generate sinusoidal energy from there. Okay. Okay. Next, the last one, what is told, the saline pole construction cannot be made strong enough to withstand the mechanical stress at higher speed. So, as we know, it cannot be used for the high speed. So, its mechanical structure is not so strong, so that when high speed there will be some crack or damage in the system. Okay. Now, coming to the next cylindrical rotor type. Okay, these are actually used for where we need very high speed. So basic difference between saline pole and cylindrical is saline pole is used where we need lower speed, and cylindrical pole is used where we need higher speed. Now cylindrical, so what are the points I have mentioned over here? Cylindrical rotor is non-projected surface type, correct? Cylindrical, so it has a sharp periphery of this kind of rotor. That means in between stator and rotor, whatever air gap is there, that location is uniform. So if it is uniform, so whatever EMF is induced, that is uniform in nature. So that's why it has a less vibration. It can be used for the higher speed. Okay, so these are the features we have for the cylindrical rotor type. So cylindrical rotor is non-projecting surface type. Cylindrical rotor type rotor has small diameter and large length, correct? Cylindrical rotor type is used for the high speed as I have mentioned, and uniform air gap as I have mentioned. Cylindrical rotors have 4 or uh, more poles, correct? Now one thing is there that this synchronous generator, so as the name listed, that the synchronous speed or the rotation of the flux speed is same as the rotor speed. That means here we can say that ns is equal to nr. Ns is the synchronous speed, nr is the rotor speed, and both are expressed by the same formula 120 F by P, where is the F is the supply frequency, P is the number of poles. Okay, so here as you can see it can be used where we need 15003,000 rpm, so it is used for a very high speed machine. Okay, so now coming to the next part, armature reaction. So basically armature reaction we have done in a DC machine. There we have seen the demagnetizing effect, cross magnetizing effect. So in one line, if we want to say what is armature reaction, so that is, so flux is generated in the field winding. That flux is cutted by the armature. Now in the armature EMF is induced. Now when this armature conductors are connected to some sort of load, so the armature winding circuit is complete. Now when the armature circuit is complete, then there is a flow of current, and when there is a flow of current in the armature, so it is generating its own flux. So this armature flux is actually destroying the main field flux. So basically this phenomenon is known as the armature reaction. Okay, so now let us see what I have written over here. Every rotating electrical machine works based on Faraday's law. Yes, correct, already discussed. Every electrical machine requires a magnetic field and a coil with a relative motion between them. Yes, there should be a flux, there should be a coil, so that both can be cutted by each other and there is EMF generation. Next point, in case of an alternator, we supply electricity to the pole to produce magnetic field, and output is taken from the armature due to relative motion between the field and the armature, the conductor. Okay, that means the same thing that I have told, that is written over here. Now we are going to see what are the effects of this one. See, I have written over there, the armature reaction of alternator depends on the phase angle. Now just think about that when armature conductor is connected to some sort of load, so that time armature conductor has some EMF, armature conductor has some current. So due to the nature of the load, so there must be some angle in between um, the voltage, armature voltage and armature current. So I have considered over here the angle between them is theta. So theta can be of three types. Zero, that means it is unity power factor, that means we can say that whatever load is connected, that is resistive in nature. Then theta can be of 90 degree, lagging zero power factor. Okay, then if it is lagging zero power factor, there will be leading power factor also. Yes, I have written over there number 3, when theta is equal to minus 90 degree, it is leading. So let us see what are those. Okay, so as you can see over there, when theta is equal to 0 at unity power factor, the angle between armature current I and induced EMF E is 0. That means they have no angle, they are at the same plane. So that's why there is no angle when theta is a 90 degree. That means a lagging power factor is working over there. When it is a lagging power factor, so that time we can say that it has, the current is lagging behind from the that means armature current is lagging behind the armature voltage by an angle 90 degree, correct. And the last one is theta is a minus 90 degree, that means the leading power factor, so reverse case of the lagging power factor. That means now the armature current is leading from the armature voltage by an angle 90 degree. So this is the perspective depending upon the load. Okay, next, armature winding. So there are actually different kinds of winding, because this is a three-phase winding. So winding can be placed mainly two types. One is concentrated winding, all windings are placed at together, and next one is the distributed winding, where the windings are distributed all over the structure. Okay, so some information is given over here. So what are the information? First and most important property of armature winding is two sides of coil. So there is a coil. So two sides of that coil should be under two adjacent poles. Correct? So that means coil span is equal to pole pitch. Correct? The winding can either be single layer or it can be double layer. So we will just see after that what are the pictorial representation of those, so that you can very easily understand what are the different types of winding we have. Next one is the winding is so arranged in different armature slots that it must produce sinusoidal wave. correct. So the distribution is in such a way so that it can generate some sinusoidal EMF, correct. So next coming, okay, now we can see what are the types of armature winding. We have single phase winding, lap winding, wave winding, concentrated winding, full pitched coil winding, and factorial pitch coil winding. Okay, factorial pitch means it's a short pitch. There is a full pitch winding and there is short pitch winding. But in our daily life, whatever machine we use, generally all machines are mainly short pitch or factorial pitched. No, these are the pictorial representation. So single phase and polyphase armature winding, lap winding. Next is a wave winding. So as you can see, the previous one, just see lap winding. So it is just like it is just lapped. It is rotation is there, then it is coming to the next. And in case of see wave winding, it is flowing like a wave, a single turn in each slot. So this is a concentrated winding placed, all windings are placed together. Next one is rating of the alternator. Okay, so rating of alternator is very important because as an electrical engineer you have to know what is the rating, what is the specification it is given to an alternator, so that just viewing that specification we can understand many things about that alternator, correct. So the specification, the power rating of alternator is given in kilowatt actually. So let us see just these are the points I have mentioned over here. So there is a copper loss section point I have mentioned. Yes, obviously there will be a copper loss because when there is a huge conductors are there and conductors are all made of copper, and when load is connected to the armature binding, so there is a closed loop current is flowing through the alternator, and due to that there will be some heating, and due to that heating there is a loss. So that loss we have to incorporate when we are finding out the power output of a machine. So in alternator we have both kind of losses. One is the coal loss, second one is the copper loss. So including all those we have to find out the rating of an alternator, because rating means the power rating means whatever power it can give output from the system, neglecting the core and copper loss, not neglecting, after calculating, and after that we have to separate that one from the output, and then we have to say that okay, at this voltage, at this frequency, at this current rating, at this speed, this machine can give this amount of power at this specific condition, at this temperature, at this pressure. So those points are very important because all weather conditions, different states, different country has different weather conditions, and different factory has also has the different working experience. So depending upon that we have to select which kind of alternator we are going to use for our particular industry. Okay, so this is the standard specification I have mentioned over here of our alternator. Kilowatt rating 5000, power factor I have given 0.85, lag, kVA rating 588000, stator slot okay mention, stator ampere mention, rotor voltage mention, rotor ampere mention, rpm what is the speed of the machine that is mentioned, frequency hertz it's mentioned, how many phase it has, 3 it is mentioned, armature connection double star. Remember always over the armature you always try to make star connection so that we have a neutral point. Okay, coolant, yes, it is using a water and hydrogen coolant, so that means it is, we are discussing about alternator which is large in size, so that's why we have to use coolant to maintain the temperature of the windings of that alternator, correct. So gas pressure 3.5 bar, okay, insulation type plus F, and specification it is something into ISO specification, something like that. So like this way all alternators can be specified. So you have to understand and you have to point, remember those points, that when you are going to visit an industry or you are going for a job in any industry, you have to check those points, and from there you have to understand about the alternator. Okay, so this is all about the basic concept, and basic construction working principle of an alternator. Thank you.